Yes. As I get wealthier, I get less and less likely to want to play a gamble for plus or minus 10% of my wealth. Now, you could argue that's true. As people get wealthier, maybe 10% starts to feel like a big number, so I'm less wanting to play that gamble. However, this is the problem. Quadratic utility function implies increasing absolute risk aversion. And that means that as I get wealthier, I become less and less willing to play this gamble for plus or minus £10. So if I'm a billionaire, I'm much less likely to be willing to gamble £10 than I am if I have no money at all. And that is just so far from our intuition of what is reasonable to assume of humans, that it tells us that there's something very wrong with using the quadratic utility function as the foundation for our portfolio theory. So to summarize here, and by the way, this is not trying to take a dig at Markowitz. Markowitz was writing in 1953, where he came up with an approach to portfolio theory that was completely novel, really sophisticated, particularly given the fact that at that time, everything you did had to be solved with a slide rule and a piece of paper and a pencil, right? So he had the fact that he could at the time come up with an approach to portfolio theory that was usable and functional and nonetheless encoded a lot of intuitions about human behavior is a remarkable achievement. All I'm saying is that in order to get there, he had to take some shortcuts. And those shortcuts were either, I'm going to assume the world is entirely Gaussian, or I'm going to assume that people only care about risk and return. We can see that neither of those things can be true. And so we have to ask the question, if Markowitz was to do this again now, with our current behavioral knowledge, what would you do? You wouldn't choose quadratic utility, but how would you approach this? And I am going to pause there. Let's take a 10-minute break, and we'll get onto that when you come back. I need some water.
spell in French. You can't spell it in English. You can't write in German. Use that.
Let's get going. Thanks. Yeah. Cheers. Okay, thanks all. Any questions on the last hour, any aspects of this that we have discussed? Sure. Yeah. Maybe if I give a slightly different example that would help, or a more tangible example. So imagine we have, let's imagine there are just 5 outcomes. And these outcomes are, I've got some distribution, so I could lose 50 with 20% probability. I could lose 10 with 20% probability. I could get 0 with 20% probability. I could get plus 10, or I could get plus 50. So I've got a completely symmetric gamble here with 5 outcomes that are all equally likely. If I look at the cumulative probability, the crucial thing here is that cumulative prospect theory is a special, is a model that is a special case of a broader class of models that are called rank-dependent utility models. And what it means is that the weight I give to each outcome is dependent not only on its probability, but in its rank relative to all these outcomes. So if I rank them as I have done here from the worst outcome to the best outcome, and I work out the cumulative probability as I go, the cumulative probability of getting at least that is 20%. Here is 40%. Here it is 60%. Here is 80%. And the cumulative probability of getting at least that, I'm 100% guaranteed to get that or less, right? What this is saying is that the probability distortion function is applied to this column. And it says, expected utility theory says I take each of these outcomes, I pump it through a utility function, and then I multiply it by this column. Okay? Cumulative prospect theory says I take each of these outcomes, I pump it through the value function, which is different, and then I multiply it by a function on this column. I multiply it by an amount that is a function on this column. So that function, there is a distortion function here that says the gap. So what I'm seeing here is I'm transforming these cumulative probabilities, and what I would do is I will be applying the distortion function I'll be applying probabilities as though, for example, instead of using 20 here, because it's an extreme outcome, I'm saying that's sort of more like about 30. So if I start building up the cumulative probabilities, what you go is that the increment here might be 20, so I'd get to a cumulative of 50. Here, I may only apply 10, so I'll get to sort of back to 60. Here, it'll be, instead of 80, I'll end up at 70 and 100. So what I've done is I've made the cumulative function higher at the bottom end than it should be, and I've made it flatter in the middle, so the gaps between 50 and 60 and 60, 70 is very flat in the middle, and at the ends, it goes back up again. So what I'm effectively doing is if I now back out the probabilities, yes?
Are you just essentially, as other way of saying it, are you just essentially manipulating the skewness and the kurtosis?
In this, you are doing it as though you are manipulating the kurtosis. So yeah, what you're doing is you're subjectively increasing the kurtosis in the way that you use the probability. Yeah. So if I now say, let me back out the probabilities that this implies I would be using, so instead of, I take it back from a cumulative to a normal probability distribution. Let me write it here. Sorry, should have left myself more space. But basically, we're going, this one, instead of 20, I give it a weight of 30. This one, I give a weight of 20, because the cumulative goes from 30 to 50. Here, I give it a weight only of 10. Here, I give it a weight only of 10. And this one, I give a weight of 30. So what I'm effectively doing is I distort the probability so it gives more weight to the ones that are very high and the ones that are very low. And so what that means is I am making a decision as though this probability distribution has more kurtosis than it in fact does. Okay. Anything else? Cool. So, blah, 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 blah. Okay, this one we've seen. So this is not the probability distribution. This is simply the value function, just to kind of burn it back into your brains. Concavity for gains, convexity for losses, etc. Now, the question that arises here is, if people do not obey expected utility theory when they make decisions, if we are optimizing a portfolio for people, and traditionally we have used expected utility theory with a version of expected utility quadratic theory that doesn't represent how people should think about risk aversion, etc. Why don't we go completely to the other extreme and we go, well, if people make decisions according to something that looks like primitive prospect theory, why don't we assume that those are their preferences? I mean, this is what they're doing, right? These are the choices that they seem to be exhibiting. So why don't we instead build an optimization procedure that, instead of maximizing mean variance, which is equivalent to maximizing quadratic utility on wealth, why don't we instead build a portfolio optimization process that maximizes the prospect theory value of these outcomes? And one answer is it's bloody difficult to do. Because of all these distortions, because of a probability distortion function and a value function that is reference dependent and has concave and convex things, this is not a convex problem to solve. So it's got bit squared points in one direction and bit squared points in another direction. Fortunately, there were some very clever mathematicians in Oxford University who thought this was a fun problem to work on and managed to build a portfolio optimization technique that did, in fact, optimize portfolios for cumulative prospect theory preferences. The problem with that is, my question would be why? Why would you optimize a portfolio for someone such that your optimization objective includes a whole bunch of irrational, stupid things that people would rather they didn't do? So it's a nice mathematical exercise, but if we start building portfolios for people based on their descriptive preferences, what we're doing is we're stepping away from being able to say, hang on, there is a right way of looking at this. You're just basically going, well, we're just going to model whatever it is you do anyway, regardless of whether you're a financial specialist or expert or not. I'm going to measure your preferences. I'm going to assume that those preferences are rational and sensible and what you really want over the long term, and then I'm going to build a portfolio that matches that. So that, to me, swings far too far in the other direction. And the question then is, if expected utility theory on quadratic utility we can't buy into, and we can't buy into just saying preferences are descriptive, so we'll use those, what can we do? And there's this space in the middle of, instead of descriptive and normative, in the middle we should have something that is prescriptive. It says, here's how we will accept that there is potentially a normative solution, and we will accept that people deviate from that in their behavior. And our job is to try and find a solution in the middle that says, here's the right thing to do, but we know you find it difficult, so we're going to help you to get as close to the right thing as possible. First, what we have to do, however, is improve the right thing, because Markovitz's right thing, mean variance optimization, did not get there. It's got these unrealistic assumptions built in. So what I'm going to do for the next hour is say, how do we change the normative model away from mean variance optimization to rest it on a more reasonable utility function that we can buy into with our current behavioral knowledge? And so the question we want to ask here is, we want to give people a normative solution. We want to give people a portfolio that is rational. It shouldn't reflect framing. It shouldn't reflect all these mad behavioral things that people actually do. In order to do that, traditional economic theory says, well, we'll just assume that people don't exhibit any of these biases. We'll assume that when they look at gains and losses, they treat them mentally as though they're 45-degree line. People process monetary outcomes absolutely logically. There's no curvature. But they have a rational risk aversion. They're rationally risk averse. And so what we should see is that their behavior is reasonable, is normative, is well behaved. We don't see that. What we see instead is that people act as though their intuitive system, all these behavioral things that we've been talking about last time, effectively distorts their perceptions. So we can actually start to have a model where we go, there is a normative self. There's something that we should do. But when we actually observe behavior, we observe that the behavior is all over the place. What we want to do is to try and separate these things into two piles. So if this is the problem we have, this is what we observe when we observe behavior. We see something like cumulative prospect theory. Classical economic theory says, well, that's nonsense. It's irrational for people to be risk-seeking. It's irrational to have reference dependent. We should optimize a portfolio for this. And that would sort of assume that they've kind of ignored any biases there. So we reject this. Now, the two extremes of the continuum are, one, we take the position of classical finance theory, and we completely ignore this, and we assume that people are unbiased, and we say, I'm going to optimize for this. The second position is we go, this is the position of the descriptive of those Oxford mathematicians who go, well, we can't really observe this, and people don't behave like that anyway, so I'll ignore that and I'll optimize for this. The position that I believe we should get to is to say we recognize that people are biased. People have behavioral responses to things in the short term, in the immediate context, that are important to them at that time, but are not things that they would want to have reflected in their portfolio over the next 20 or 30 years. So what our job should be is to try and find out the best model for the normative solution as possible, and then recognize that people have discomfort with that normative solution. People are biased along the way, and then build tools to help them mitigate and control that discomfort. So what we first need to do is to rework Markowitz so that this is grounded on a non-quadratic utility function. We will then figure out how to optimize the portfolio in that normative rational way. And then in the last lecture we're going to come back and go, well, that's fine. We've just told people what the right answer is, but we haven't actually given them any help in achieving that right answer because they're biased. So we want to help them to control those biases. So that's what we're heading towards. The implication of the Markowitz thing and the, where's it gone? The Pratt-Arrow risk aversion and the increasing absolute risk aversion, etc., is that something in this traditional model is wrong. And we can pinpoint two places where it's likely to be wrong. One is this function, because this indifference curve derives directly from the utility function that you choose. If I choose a quadratic utility function, it will imply a very specific shape of the indifference curve by which I am indifferent between expected returns and risk. It also tells me that this risk thing here does not include all of my preferences over variability, because it only reflects the first moment. If an investment is put onto this risk-return thing, and I go, here is an investment that, let's say, for example, it has 10% expected returns, it has 15% standard deviation, it would sit there. If I take another investment that has 10% expected returns, 15% standard deviation, exactly the same, but has a positive skew, in this diagram, it would sit in exactly the same place. So the problem with that is that this risk-return dimensionality basically assumes away all mechanisms that enable us to treat skewness and kurtosis into this problem. So we have to think, firstly, how do I change this indifference curve? And secondly, is there something I can do to, instead of reflecting all the variability in assets just through the first moment, Is there something I can do to this measure that incorporates the fact that people actually have preferences for skewness and they have preferences for kurtosis? So those are the two things we're going to try and shift in moving forward. And what we are going to do is we are going to effectively say, I still want to draw a picture in risk-return space. But when I talk about risk, I'm not just going to talk about standard deviation. I'm going to talk about all the things that people care about, all the deviations away from expected return, because people will care about the whole shape of the distribution. So we're going to call it behavioral risk, partly for the lack of anything better to call it. But we're going to see if we can derive a risk measure that is a better normative description of what people should care about when they think about the risk of a portfolio. And that will enable us to also say, how then do people trade off that risk with return, and gives us a more complete description of what we're trying to optimize for. So the question that arises first is, if quadratic utility is not the utility that I should be thinking about, what is? I've got to plug something else in. I don't want to throw expected utility theory away because it is a normative model. It's a model that embodies a lot of what it means to be rational. So I've got to replace quadratic utility with something else. And we can think that in the spectrum from stuff that's really normative, that I absolutely want to retain, to stuff that's really descriptive and superfluous and just a function of the here and now, but not actually my deep-seated preferences. Some of it I want to retain, and some of it I want to throw away. So stuff I want to throw away. People make errors. I don't want to embody an error rate in the optimization process, right? If people are making errors because they have inconsistent choices, I don't want to build that error into the utility function. Failures of dominance. If people are choosing dominated alternatives, that may be what they do right here, right now, when faced with a particular set of choices. It's not what they would want us to do for them in optimizing a portfolio over 20 or 30 years. And framing effects. Framing effects is I change my mind simply when the same set of choices is portrayed to me slightly differently. I should not want to build framing effects into my optimization procedure. So exclude all of that stuff. That's the stuff we want to put on the side and come back to later. On this side, there's stuff I definitely want to include. I want to include risk attitudes. It seems pretty much incontrovertible that if I am trying to optimize a portfolio, that I should be trying to minimize some measure of risk. I should not want people to be seeking out risk without being paid for it. So if I take on risk, I should expect to see higher expected returns as a result. I would definitely want people to use accurate probabilities, because if I'm not using accurate probabilities when I'm optimizing, then I'm basically giving away information. I'm doing something that is based on an invalid perception of what the world is like, and it means I'm going to get worse returns as a result. And I should also be thinking about long-term utility. If I'm trying to build a portfolio that's going to be run for the next 5, 10, or 15 years, I don't just want to be reflecting my preferences right now, because frankly, when 15 years arrive,